So I had this idea for a long time to create an interactive application using the C programming language and Realip. I came across this website that shows a chess game and you can smoothly change board positions and it animates the pieces moving. This was what I wanted to recreate in Realip. So I went forward and I went to ChatGPT and then I asked how to install Realip on my computer. So I specifically wanted to get Realip installed on Linux. Here I am pasting the commands from ChatGPT into the terminal to install Realip so that I can use it. But it doesn't go as planned, as there was some errors in building the source. So I ended up doing some research and then I stumbled upon the actual official documentation of how to install Realip from the source. So I found that one and then I followed those instructions and I could finally be able to install Realip on my computer. And then I started to import Realip into C and then I started to code. So to get a head start on creating the project and creating a boilerplate for this code, I asked ChatGPT to give me an example Realip code, like a hello world if you will, into Realip, and that I got some idea of like what I need to call, like what functions I need to call to draw certain things on the screen. And I experimented with like, showing colors on the screen and trying to get comfortable with the API, because this is my first time working with Realip. And then I created a Git repository and a README file and built instructions for the project. And then I uploaded this entire thing into GitHub on my personal account. And then that's the beginning of creating the project. So after the initial boilerplate code was done for the project, I started to work on creating rectangles to represent a chess cell in the grid of the chessboard. So I asked ChatGPT how to do that and how to draw a rectangle. And then once I found out the method, I started to create a function that holds the chessboard. So the structure would hold all the chess pieces where they are, and also it will help us in drawing the chess grid. So in this function called drawBoard, I am trying to create a function to draw the chess grid on the screen, playing around with the colors and trying to see what I can do to make it as visually appealing as possible. And now you can see I have accomplished in creating a chess grid, two alternating colors, and afterwards I'm trying to see if I can get sprites to be drawn on the chess grid. So the sprites are the chess pieces. So I found some chess PNG files to represent like the chess pieces, and then I am trying to see, experimenting with how we can draw images using Realip onto the display. So I came up with a small example class called image_example.c to play around with the images to see how you can draw these images onto the screen. And here I am trying to call a method called drawText that allows you to draw these sprites onto the screen. So this is a bit of an involved process. First you need to load the image data into the memory, and then after you need to create a texture from that image representation, from that memory representation, and then only you can draw it into the display. So because C is very low level, you need to do all of these steps in order for it to work. So here I am trying to see if I can give any code names for these pieces. So I represent them in like a hexadecimal format, and then I can easily identify which pieces are where in the grid, and based on which ID I can draw the corresponding image. So I'm creating a function called initBoard to initialize the entire board and the pieces. So when it's initialized, there are no pieces on the board, but as time goes on, you can add pieces into the board at different XY locations. And based on the XY locations, we need to identify which piece is there and then draw the piece. So this was a bit of an involved process because you need to manage the memory, and you need to load the images, and then you need to track everything. So I'm trying to create certain functions to load all the images onto the memory, and then create textures from them, and then trying to render them into the screen. So this was a bit of an involved process. I needed to load every image from the file system into the memory, and then load them. And I kept them in the memory as long as the program ran, and then I could reuse those the images from the memory, and then draw textures. I even pre-calculated the textures as well, so that I don't need to re-render them every time I need them. So for each piece there is a texture, and in the board we store what the ID of the piece is. And then when it finds this ID on the grid, it will try to find the texture and then render that onto the screen on the XY positions. So that was very efficient, and it was very fast. And so you can see that I am now experimenting with different board positions and trying to see how it works. So that's what I'm doing right now. I was trying to come up with a way to find the difference between two chessboard positions. So you need to know the difference between two chessboard positions to know what has changed and what has remained. So there are certain differences. So for example, pieces can go missing, like pieces can disappear, but new pieces can appear in different board positions at different places, or the pieces can switch their location, like their position. So in one board position the king might be in the corner, in the next board position it might be in the other corner, or something like that. So to represent all of those differences, I created a diffing function that finds the difference between two chessboard positions at a given time. And all of this information of the difference, I stored them in another C structure that I used to keep track of which pieces have changed and which pieces have remained the same, so that I can use that information to then animate the board positions. So I can smoothly interpolate between the two positions, since I know what the information are, like what the differences are. So based on those the differences information that I gather by analyzing the two board positions and comparing them, I get the information of the differences, and then after that I can use those information to basically come up with the animations. So that's what I did. So I'm currently creating and researching on how to do that function, and then I'm implementing it. So I'm frequently communicating with ChatGPT, and then I'm coding my own algorithm by getting some ideas from ChatGPT as well. So finally, after some failed attempts, I was able to create a result that I'm proud of. I was able to create the first animation. So you can see now I'm testing it. The board, the pieces move now to the other positions once you change the board, but still there are certain issues with the animation. So I'm trying to fix them as well. So after a while I found out the issues and I tweaked them and I fixed them. After that I tried to see if I can actually come up with a real world example, like some famous board positions, and I manually tried to enter those board positions into the code, and I recreated two of famous games, board positions of some famous games, and I was able to add them into the program. So my idea was to interpolate between the two board positions that are very different from each other, and to see how it works. So I think in the end it will be a very good result, because these are from two separate games and in two separate periods of time, and it would be nice to see how the pieces rearrange themselves once I have recreated these board positions. So this is the final result. As you can see, now the positions smoothly interplay with each other, and the pieces that don't belong disappear, and the pieces that are new appear, and the other pieces just move. If there are no changes, the pieces stay at exactly the same place. I hope you guys enjoy the video. I have added the link to the source code in the description below. If you have any further questions, please leave a comment and I will answer them. Subscribe to the channel, and thank you, and stay safe. Goodbye.